Hi, this is Michael Guest from Persist, and I'm going to show how to do the processing of the two-channel EEG with custom electrode labels using Persist 13. We're going to use Insight 2, which is part of Persist 13, but the program icon is not installed on the desktop. Easy enough to do. If you go to C, Program Files, x86, Persist Insight, there's insight2.exe, just right-click, and while holding down the right mouse button, copy it to the desktop, and then you get a shortcut for there. So I'll go ahead and cancel that because I already have a icon on the desktop. And there are our files. This is the EDF file that was sent, and these are a couple of results files from the processing that I've already done. I'll show you how that was done. I'll go ahead and minimize this for a minute. I'll launch Insight 2 from the desktop. And here it is. This is an earlier user interface for the program. So the internals are modern, but this one has more buttons, more pieces to the user interface. This is going to be a bit easier to use for the custom settings and so forth that we'll be using. And if I go ahead and bring up the folder that has the recording in it, I can just drag that recording onto the interface and Persist. Now, the first time you open it, it'll ask you to confirm the type of file, whether it's a EDF90 or a telefactor EDF. Just tell it that it's EDF90. This one's already been processed. We have some detections over here on the right. And I'll go ahead and open up this window just a little bit. And we can see that we have the text, the time, the duration, origin, and so forth. So if we go ahead and select the drop down here, we can show just the spike detections. That gives us a little bit different information. This not only shows the time and the scalp sign, but it also shows the perception, which is a probability that the algorithm believes that this is a spike, or that a human would mark it as a spike. And we can sort that just by clicking on any one of these columns. So how did we get there? So first of all, I created a montage that had just the two channels of interest. I'll go ahead and select the recorded montage. By default, you may pull up the program, open up a recording, and it's going to show a bipolar longitudinal montage. There are no 1020 channels in this recording, and so going to the recorded montage, regardless, will always show you the raw recording, which is in this case the DSQ and the PSQ channels to the common reference. So once we select the recorded montage, then we can save this as a montage we can use for review and for performing the spike detection. Let's go ahead and select Save Montage. This is where you'd put in the name. I've already done that, and I saved it as Z2CH, 2-channel. Now, once I have the montage, then we can tell one of the detectors to run on this recording. So if we go to Tools, we can scroll down to Reveal, and this is the previous generation spike detector. We still have it in the product. It'll work with any channel labels, any gain, any number of channels. The Persist 13 spike detector is different. That one is specifically trained for scalp EEG for 1020 or 1010 or anything in between those two. And it uses spatial information to help do its spike detection. This one, it'll perform its detection just based on morphology, topology, and field. In this case, we only have two channels, so the field would be, does it show up in more than one channel? And it's going to look at breaking down the EEG into segments, and then looking for something that stands out from the background, isn't too sharp, isn't too slow, and has a slow wave. That all improves this probability over on the right, this perception value. So let's go ahead and go to Settings and Protocol. And the way I created this one is for the spike detection montage. I just went ahead into the drop-down list here, and I selected the 2-channel montage. I'm going to leave the gain at automatic. If that doesn't function properly, for whatever reason, for instance, if the first few minutes of the recording are not EEG, or more than half of the first few minutes of the recording are not reflective of the background amplitude, you may have to set this manually. To do that, you just deselect this. And we are looking at this at 10 microvolts. That's what's selected up at the top, so this is fine. It may adjust that a little bit one way or the other. But if you find that the detection is not functioning as you'd expect, setting this manually is probably not a bad idea. unless you have unusually high or low gains, or again, the first few minutes of the recording isn't good enough quality for it to set its gain automatically. So that's fine either way. Low filter, high filter. Notch filter I'm going to set to 50 Hertz. There's also a combined notch for some of the analysis engines. And so if we don't know what the mains frequency is, this is a good option. It'll use both in case you don't know what the recording came from. Of course, we know this one came from a 50 Hertz environment. We can leave that as it is. Now, the rhythmic burst montage is just looking for an evolving rhythmic pattern. It may not be something that you're interested in having detected, but we'll go ahead and do the same thing. We'll select the 2-channel montage, and we can set the gain automatically. We'll set our notch filter to be the same. Now for the settings, this is where we're going to set the thresholds, and we're just really going to look at the spike detection thresholds. Again, this is a probability. These numbers are lower than the defaults. I've lowered the notify settings to 0.5, so it's on a scale of 0 to 1. And the detection, I put at 0.1, the most sensitive. There's an auxiliary program that you can open to increase the sensitivity, which means lowering this threshold without rescanning. With this notification at 0.5, I think you're going to find a nice balance, at least on this individual recording, of sensitivity and specificity. Something to keep in mind as well is this detector was not trained or tested on 2-channel recordings of this nature. So while it may appear to work fine, this is something where you also want to do a visual inspection to see how it's performing, because this generation of detector was also trained and tested on scalp 1020 EEG recordings as opposed to 2-channel. And looking at this recording, I just set the threshold to 0.5 and looked how it performed. It seemed to do a decent job with this particular EEG. You should test it on additional ones to make sure. So the only thing I changed here was the spike line. I've left these other parameters as the default. I also selected store detailed spike information. This is where we get duration, height, and angle over to the right, and also allows us to use one of the auxiliary review programs to go through the spike detections. So I'm going to go ahead and close this. I'm going to save these settings, save protocol, and I'm going to hit OK to overwrite that. And then I'm going to hit process. This last 10 minutes is just a histogram window. You don't have to worry about that. And what it did was it deleted the previous spike detections, and now it begins processing through the recording. When it's finished, it'll just say waiting for data instead of processing in this window here. So once it reaches the end of the file, go ahead and either click pause or hit the X in the upper right to close the detector. And then over on the right, you'll have a list of detections that we were just looking at prior to hitting the process button. And you can see here it's just beginning to do some detections. So if there are any questions, feel free to send me an email. I can create other screencasts, or we can meet through a web conference, but this should get you started. Thanks so much.